In this video, we're going to work backwards. I'm going to give you the percent, and you have to find out the value that corresponds to it. So we're still working with our newborn seals. Okay, so it says newborn seals in the bottom 10th percentile will probably not survive. Given that newborn seals have a normal distribution with a mean of 29.5, a standard deviation of 1.2, find the 10th percent. So we start off the same idea as we did before. We're going to draw a picture and then shade the part that pertains to the question. Okay. Now you notice again I marked this off. Here's your mean at 29.5, and we went one standard deviation out for 3 marks. That's because almost all your data is within 3 standard deviations of the mean, and the same thing over on this side, 3 marks below, each one going by a distance of 1.2. Okay, now instead of labeling a value here that we're looking for, I'm actually going to label how much I have shaded. So in this case I shaded 10%, okay, because we're looking for the 10th percentile. A percentile means that's the percent that fall below that value. Okay, so now we had to find the z value where 10% are less than that value, so we're going to be looking for 10% in the table. So I'm going to go over to my table. Okay, remember we just went to chapter contents, and appendix A is the tables. And I don't want the random number table, and let me zoom it out so we can find it. Okay, now we're looking for 10%. 10% is 0.1. So if I go down through this column, you see here, oh, I'm at 0.09, and then I'm at 0.1151. So it's in between negative 1.3 and negative 1.2. Okay, so now we just come over here until you get between, here's 0.1003 and 0.0985. So it's between this value and this value. Normally I just pick the one that's closest to it. So I have negative 1.2, and then I'm in the 08 column, so that's negative 1.28. Okay, so that's, I just have that little bit of the table showing here. So we're right here. There's my negative 1.28. Okay, so that tells me my z value. Remember, I need to know the weight of the seals. Okay, so what I need to do is I need to use the z formula, except now I know z and I'm trying to find x. Okay, so I can take this formula. You can either just plug the numbers into it, or plug the numbers into it and solve for x, or I can rewrite it like this, solving for x to start with. Okay, tests and quizzes, you can use either of these two formulas. This one's easier if you're looking for z, this is easier if you're looking for x. They're the same formula, just written 2 different ways. Okay, so now that I have that, I know x is, I put my mean in for mu, plus my z, which was negative 1.28, times the standard deviation, which is 1.2. Again, make sure you have your calculator, then you understand how to do this calculation on your calculator. And I come up with 27.964, or about 28 inches. So baby seal that is less than 28 inches will probably not survive. Okay, so that's using the table what I call backwards, because I'm giving you the percent, you're trying to find the observation. Okay, and the last thing I want to talk about in this video is the empirical rule. Okay, so we know what I told you for the empirical rule was that 68% of the data will fall within 1 standard deviation of the mean, 95% within 2, and 99.7% within 3. Okay, so if your distribution is exactly normal, then these numbers just correspond to areas on the normal curve. Okay, what I'm going to do next is we're actually going to use the normal table, because these values are values that just kind of make it easy to remember. The 68 and the 1, the 95 and the 2, and we're going to see what the values actually are. Okay, so what I'm going to do is I'm going to draw a normal table, and I'm not really good with my pen here, but we'll try this anyway. So my pen isn't, oops, I think I need to get my pen first. Okay, so first I'm going to draw a normal distribution. Okay, it's much easier on paper and pencil than it is on my computer, just so you know that. Okay, again, I'm just going to mark this off, and they should be equally spaced, which did not really happen, right? So this is 0, right? And if I continue on, here's 1, 2, 3. So this is going to be -1, -2. I know sometimes it's easier to actually see me work through a problem instead of just putting images up on the PowerPoint. So, okay, we want the middle 95%, and we know it's somewhere around in here. Okay, so I'm going to do 95, then we'll come back and do 96. That was supposed to be right at the 2. And this piece here is 95%. Okay, remember the table though always tells me the part to the left. So if I do my shading, this part's 95%. So now I need to figure out though what this part is, because that's the number I need to look up in the table. Okay, remember underneath the whole thing is 100, so I'm going to do 1 minus 0.95, which gives me 0.05. Oops. Okay, and then we're going to take that 0.05 and divide it by 2 because it's split between this piece and this piece. And since the whole thing is symmetric, I know that those two pieces are equal. So if I take the 0.05, divide it by 2, oops, I get 0.025. Okay, so that's the number I need to look up in the body of my table. So I'm going to go over to my table. Remember, look up 0.025. So I'm going to go down here. We're at 0.00s. Here's some 0.01, 0.028. So it's in between these two numbers, which makes sense that we're close to that -2 value. Okay, so I'm looking for something close to 0.025. 0.02. Right, I forgot number. Yeah, 0.025. And actually I should say it's in between these two values, right? That where I was? 0.025 is right here at -1.96. So let me flip back over to my page here. So to get this, I'm going to get z equal to -1.96. Now remember, we said that 95% of the data are between 2 standard deviations of the mean, and that's what I have, very close to it. Okay, so it's much easier to remember that 95% of the data are within 2 standard deviations of the mean versus 95% of the data are within 1.96 standard deviations of the mean. So that's kind of why they just say it's 2 instead of 1.96. So let's do the same thing for 1.68. So again, I'm going to draw my normal distribution. We're going to follow the same process. Okay, here's my 0. And then I mark off 3 standard deviations. And I don't have to worry about converting these numbers because we're only just talking about the standard normal right now. Okay, so there's your 1, 2, and 3, and -1, -2, my pen jumps around a lot, and -3. Okay, so now for 68%, I know 68% is between -1 and +1, so this is 68%. Okay, again, I need to know how much is down, how much is down here, because I need to know always the part to the left. So I'm going to take 1 minus the 0.68, which is 0.32. But again, that's split between the two ends, this piece and this piece, so I have to divide the 0.32 in half. Which gives me 0.16. Okay, so now we're looking at 0.16, and we know it's going to be somewhere around -1, right? So back over to my normal table. Okay, so we're looking for 0.16, right? And here's some 0.15, and let me get on the right line here. If I come down, down this row, again I get 0.16, right? So notice, remember we said it's about -1, and that's actually about where I am, okay? Between -1.0 and negative 0.99, right? So that's actually not too bad. It's probably about halfway in between there, which would be about negative 0.995. Okay, so again, we just use 1 because that's an approximation. We can also use crunch it. Okay, again, I'm in the under stat, calculators, and normal. Okay, now this time we know the answer to the probability, the shaded area. So I'm going to put a value in here. So in this case, so if I'm doing the 95%, it was 0.025. Standard normal, so my mean is 0, standard deviation was 1, and that's the part that's less than it. So I hit compute, and there's the negative 1.96 that we came up with over using the table. Okay, if I do it for the 68% rule, this was 0.16. Again, 16% that was left of what I was looking for. Press compute, and remember we came up with it was between negative 1 and 1, or within 1 standard deviation is 68% of the data. Okay, you can do a similar thing if you're working with the 99.7%. If you take 1 minus the 0.997, that gives you 0.003, and if you divide that into 0.0015, or it's actually 0.15%, okay, and that comes up at negative 2.97-ish, and we use this within 3 standard deviations. If you notice, the only part that's shaded is this tiny little red part right there. Okay, now back to the seal problem that we did originally. I can actually do it here where we were looking for 10%, the bottom 10%. Now I have to fill in my mean, which was 29.5, fill in the standard deviation, which was 1.2. This part is 0.1 or 10%. Again, we're looking for less than. If it was the top 10%, I would need to change this to greater than, so it would give me the right thing. Press compute. And here's my bottom 10%, okay, and it's at 27.96, or we said about 28. Okay, always look at the picture to make sure you have the right part shaded for what you're trying to find. If you don't, then you may need to change this right here. Okay, if you're using this where you're filling in the percent, you can't use between. You have to always either know the part to the left or to the right. Okay, and again, this button here just makes it so you can actually see it divided up by standard deviations. Okay, now the next part you should do is look over the next 3 or 4 slides, see if you can do those by hand, and then the next video, so section 6.3 part 3 video, 6.2 part 3 video, I'll go over how to actually solve those problems. Okay, good luck working on the next slides in the PowerPoint.